Let's take a look at some sample problems from section 5-4. This is where we're calculating parameters for the binomial probability distribution. And we'll begin on page 220, actually it's 226 in the textbook, and we'll start with problem number 6. Our directions say, assume that a procedure yields a binomial distribution with n trials and the probability of success for one trial is p. Use the given value of n and p to find the mean mu and the standard deviation sigma. Also use the range rule of thumb to find the minimum usual value mu minus 2 sigma and the maximum usual value mu, that should be plus 2 sigma. My book has a misprint. Okay, number 6. In an analysis of preliminary test results from X-sort gender selection method, 14 babies are born, and it is assumed that 50% of the girls babies are girls. So N equals 14 and P equals 0.5. So to calculate mu, we take 14 times 1/2, which gives us a mean of 7. To calculate the standard deviation, we're going to need Q. So Q will be 1 minus P. So it also is 0.5. So we'll have 14 times 0.5 times 0.5. So I need the square root of 14 times 0.5 squared, and I get 1.87, so that would be a 1.9. Okay, so our minimum usual is 7 minus 2 times 1.9. 7 minus 2 times 1.9 is 3.2. And our maximum usual is going to be 7 plus, and again there's a misprint in my book at least, 7 plus 2 times sigma, so it would be 7 plus 2 times 1.9. 7 plus 2 times 1.9, 10.8. Okay. Okay, so clinical trial number 8. In a clinical trial of the cholesterol drug Lipitor, 94 subjects were treated with 80 milligrams of Lipitor, and 6.4% of them developed headaches. So N equals 94 and P is 0.064. N is 94. P is 0.064. Q would be 1 minus 0.064. So that's 0.936. Okay, so our mean is going to be 94 times 0.064. And I'm getting 6.016. And let's see. So we went around that to the nearest tenth, it would be 6.0. And so for sigma, we want to take the square root of 94, square root of 94 times 0.064 times 0.936. Close it off. And I'm getting 2.37, so that would be 2.4. So my minimum usual value would be 6 minus 2 times 2.4. 6 minus 2 times 2.4 is 1.2. And our maximum usual is 6 plus 2 times 1.2. 6 plus 2 times 1.2 is going to be 8.4. Okay, number 10. When Mendel conducted his famous genetics experiments with peas, one sample of offspring consisted of 580 peas. So N is 80. And Mendel theorized that about 25% of them would be yellow. P is 0.25. That means Q is 0.75. Okay, so let's see what we do in part A. Find the mean and standard deviation for the number of yellow peas. Okay, so mean would be 580 times 0.25. 580 times 0.25 is 145. Standard deviation would be 580 times, whoops, missed the 80. 580 times 0.25 times 0.75. So we want the square root of 580 times 0.25 times 0.75. Close it off. And I'm getting 10.4. Okay, so part B, I want the actual results consisted of 152 yellow peas. Is that result unusually high? What does this result suggest about Mendel's theory? So, was it unusually high? We want to take our mean plus 2 times the standard deviation to see what the usual maximum would be. And we're going to get 145 plus 20.8, 165.8. So he came up with 152. So that's not unusually high. It's not greater than the usual max. Okay, let's move on to number 16. This is on page 227. We're talking about deciphering messages. The Central Intelligence Agency has specialists who analyze the frequencies of letters of the alphabet in an attempt to decipher intercepted messages that are sent as ciphered text. In standard English text, the letter E is used at a rate of 12.7%. Okay, find the mean and the standard deviation for the number of times the letter E will be found on a typical page of 2,600 characters. Okay, so N is 2,600. Probability of it being an E is 0.127. So if I take 1 minus 0.127, I get Q is 0.873. So the mean would be 2600 times 0.127 times 2600 is 330.2. Standard deviation, we're going to multiply 2600 times 0.127 times 0.873 and take the square root. So the square root of 2600 times 0.127 times 0.873 is 16.97, so that would round to 17.0. Alright, so in part B, it says, in an intercepted, ciphered message sent to France, a page of 2,600 characters is found to have the letter E occurring 290 times. Is 290 unusually low or unusually high? So, okay, minimum usual value will be 330.2 minus 2 times 17 is 34. So 330.2 minus 34 is 296.2. The usual maximum is 330.2 plus 34, which is 364.2. So they found 290. 290 is less than our usual minimum, so it is unusually low. Alright, one last one, number 18. In 18, if you place a bet on the number 7 in roulette, you have the probability of 1 over 38 of winning. Find the mean and standard deviation for the number of wins for people who bet on the number 7 50 times. So N is 50. P is 1 over 38. That means Q is 37 over 38. Okay, so we're finding the mean and standard deviation. So 50 times 1 over 38. 50 divided by 38. 1.3. Sigma 50 times 1 over 38 times 37 over 38. Alright, so square root. Okay. 50 will be in the numerator, and as is 37. So I'm going to do 50 times 37 divided by 38 squared. Close it off. And I'm getting 1.1. Okay, in part B, would 0 wins and 50 bets be an unusually low number of wins? Okay, so 1.3 minus 2 times 1.1. 1.3 minus 2 times 1.1 is negative 0.9. If we add it, we're going to get 3.5. So 0 win, 0 is not unusually low. So